Welcome to Learnpedia, the ultimate JEE and NEET prep tool that is currently being used by over 20,000 aspirants. Let's see if you can answer this actual NEET question. If you think you got the answer, then post it in the comment section below. To understand the concept behind this question, watch the video that follows.
The next term we have is coordination number. Consider the complex NiNH3,4Cl2. In this, the coordination number of nickel is 4. What do you mean by that? The 4 ammonia ligands are directly attached to the central metal atom nickel. So it is actually the number of coordinate bonds which the ligands form with the central metal atom or ion in a complex is called coordination number. If you consider an example of K2PtCl6, so here these 6 chlorine ligands are directly attached to the central metal atom in the complex compound. So the number of ligands that are directly attached to the central metal atom or ion in the complex compound or a complex ion is called coordination number. So in this complex, the coordination number of the central metal atom platinum is 6. The more common coordination numbers of the different transition metals are 2, 4, 6. So thus the number of coordinate covalent bonds which are formed by the ligands with the central metal atom or ion in a complex compound or coordination compound or a complex ion is coordination number. The lighter transition metals exhibit coordination numbers of 4 and 6, while the heavier transition elements exhibit coordination number of more than 6. Common coordination numbers exhibited by the transition metals are 2, 4, 6. For example, what is the coordination number of chromium in K3Cr C2O4 taken twice? So here the 3 ligands are there. That does not mean the chromium coordination number is 3. Here oxalate ion, each one is a bidentate ligand. So each oxalate ion will form 2 coordinate covalent bonds with the central atom. So 3 oxalate ions putting together will form 6. Hence, the coordination number of chromium, the central metal atom in the complex compound, is 6. The next term we come across is coordination sphere or ionization sphere. Consider K4FeCN6, the one which is here placed in square brackets, that is FeCN6 4 minus is the coordination sphere. That is, the central metal atom to which the ligands are attached form coordination sphere, and the potassium which is there outside the square bracket, which will come out in the form of ions as 4K plus when put in water, is ionization sphere. So thereby the central metal atom, that is iron, and the ligands that are directly attached to the central metal atom collectively is termed as coordination sphere, and this coordination sphere is put in square bracket as shown here in ferrocyanide complex. Similarly, when we take AgNH3 taken twice Cl, in this silver atom to which 2 ammonia ligands are attached, that is put in square bracket, that is AgNH3 taken twice whole plus. This which is put in the square bracket is a coordination sphere, and the Cl that is there outside the square bracket, which will come out in the form of ion when put in water, is ionization sphere. Thus, the central metal atom and the ligands which are directly attached to it are collectively called as coordination sphere, and is written inside the square bracket as can be seen here in diamine silver 1 complex ion. This is the coordination sphere. And this central metal atom and the ligands inside the square bracket behave as single entity, and the part outside the bracket is called ionization sphere. The remaining part of the complex compound, that is other than the coordination sphere, that is placed outside the coordination sphere, is called ionization sphere. Got the difference between the two? So in the example CuNH3 4SO4. The sulfate which is there outside the coordination sphere, this part is ionization sphere, and the one which is there completely in the square bracket is called coordination sphere, and the sulfate which is present outside the square bracket is ionizable, and this which is there in the square bracket which acts as a single entity and is non-ionizable, and this copper metal is the central metal atom, and this ammonia groups which are there, 4, are the ligands. Similarly, when we take another example as K2NiCN4, this is potassium which is there outside the square bracket is ionization sphere and is ionizable, whereas what all is present inside the square bracket is coordination sphere, and this nickel is the central metal atom, and the 4 cyanide groups which are attached to the central metal atom are ligands, and there being 4 cyanides which are directly attached to the central metal atom, 4 is the coordination number.
Hey there, hope you understood the concept. Here's the answer to the question that was asked in the beginning. Found this video useful? Hit the like and share buttons to enjoy more such videos. LearnPedia's JEE and NEET prep tools contain over 4,000 videos and over 20,000 questions. You can access them online through our website or offline through an SD card or a pen drive. To buy now, visit www.learnpedia.in. You can also try a free demo of the product before buying.